Hi guys, today's video is a continuation of the previous video. Because the previous video was too long, so I decided to split it into two videos. Please watch the previous video if you have not, because in that video I explained about the Greeks and their meaning. I will put a link to the previous video in the description below. So today we are going to view the Greeks on the Thinkorswim trading software. What I have here is a paper trading account from TOS. Now, a paper trading account is an account where you have virtual money to trade on the market, and you can use a paper trading account to test your strategies or get used to the software interface. What we have here is the option chain for Apple. One point I want to mention is most option contracts are for 100 shares, and the prices shown on the option chain is only for one share. So if you want to buy the 135 call option for Apple that expires on 30th April, you need to multiply the bid prices by 100. An example, the bid is $2.45, so buying this call will cost you $245. Ask prices will also be multiplied by 100 when you sell them. Bid and ask prices need to be multiplied by 100 because each option contract is for 100 shares. Now let's see how we can look at the 4 Greeks on the TD Ameritrade software. You need to mouse over and click on Layout. Then click on Customize. Here you can look for the Greek that you want to add to your view, like for example Gamma. Now another way to do this is to click on Layout and look for the 4 Greeks. Now the 4 Greeks are part of the predefined view that you can select in the layout options. Once you've selected the Greeks, you can see what are the Greeks for each option at different strike prices and different days to expiration. Now we see that Apple's current stock price is about $131 and the at the money options are 131 and 132. Another way to identify at the money options is to use the shaded background to help you, because in the money options have a shaded background. You can see that the in the money calls and in the money puts are both shaded. Okay, so for delta, we see that the delta for this call is 0.48, and we know that delta represents how much your call option will increase for a $1 increase in the stock price. The bid and ask for this option is $3.60 and $3.70 respectively. A quick recap: bid is the highest prices buyers are willing to pay, and ask is the lowest prices sellers are willing to sell. When the market is live, the bid and ask prices will constantly update as new orders are placed. For simplicity's sake, let's say it costs you $3.60 to buy this call option. If the stock price of Apple increased by $1, your call option will increase by 48 cents. Now for puts, delta is negative. Remember that a put is in the money when the strike price of the put is above the stock price. From the option chain, we can see that all in the money puts are above the current stock price. So when the stock price falls, puts are actually more valuable, and when the stock price increases, puts are less valuable. Thus, delta is negative because of its definition for every $1 increase in the stock price. Remember that the value of delta can also be thought of as the probability of the option closing in the money. For calls, in the money means the stock will be at least 1 cent above the strike price at expiration. So in this case, $132.01. Since delta is 0.48, you can think of this call option having a 48% chance of being in the money at expiration. Options that are currently in the money have a higher delta, and options that are out of the money have a lower delta. You can see that this is true for both calls and puts. Next, we will look at gamma. Gamma is the change in delta. Unlike delta, gamma only takes on a positive value. Gamma is highest for at the money options, and it is lowest for deep in the money or out of the money options. Looking at the money options, you can see that they have the highest gamma, which is 0.04 in this case. When the stock price increases or decreases by $1, at the money options experience the largest change to their option prices. And this makes sense. Think about it. For at the money options, you don't know if they will end up in the money or out of the money. So every $1 increase or decrease in their stock price will affect their option prices more compared to an option that is deeply in the money. A deep in the money option has a high probability of closing in the money, so a $1 change in the stock price will not affect it as much. You can see options that are deeply in the money or deeply out of the money have the lowest gamma. Now for Vega, this tracks the change in option prices for every 1% increase in implied volatility. As we discussed in the previous lesson, Vega is highest for at the money options and for options with high days to expiration. When you look at the option chain, 30th April, 17 days to expiration, you see that at the money options have the highest Vega. If you look at options with longer days to expiration, for example the 28 May, 45 days to expiration option, at the same strike price of $132, Vega is higher for options with 45 days to expiration compared to 17 days to expiration. This means any change in implied volatility will affect the options with higher days to expiration, which is a 45 days to expiration in this case. And for the 45 days to expiration option, Vega is also highest for its at the money options. Now Theta, the Greek that represents the time decay of your option. We know Theta does not move at a fixed rate, and Theta is higher when the option is closer to expiration. Let's look at the option with 45 days to expiration using the $132 call as the reference. For this option, Theta is negative 0.06. Now let's look at another option at the same strike price but is closer to expiration, the 17 days to expiration call option. Here you can see that Theta is negative 0.11. If we look at the 10 days to expiration call option, at the same strike price, Theta is negative 0.12. And if you were to look at the 3 days to expiration, the Theta for the $132 call option is negative 0.22. So you see that Theta speeds up when the option moves closer to expiration. This is because your options have to lose all their extrinsic value by expiration because they will have no time remaining. At expiration, your options will be either in the money or out of the money. You might have heard of another Greek which is called rho. Now rho is a Greek that tracks the change in option prices versus interest rate. I'm not going to get into rho because I don't think it's very important. But if you trade options with long days to expiration, for example options that are a few years out, rho might be more relevant for you. If you're interested in rho, you can go and Google it to find out more. Just Google for rho, which is spelled as RHO. Now one point I want to add on is, so far for most of my videos, I have been focusing on the basics, like what are the factors that affect option pricing, what do the different terms mean in the money, at the money, how do you read an option chart, what are the Greeks. The reason is because I believe having a strong understanding of the fundamentals will make it easier for you to learn the advanced concepts later on in option trading. And knowing the fundamentals will be helpful when you create your own trading strategy in the future. So I spend more time on the fundamentals and I hope you guys are okay with it. Anyway, that's it for this video, and in my next video, my plan is to take a look at implied volatility and discuss a bit more about IV. Thank you for watching. Now, feel free to leave a comment if you have any questions and I'll do my best to reply. If you found the video useful, it would be awesome if you could like the video and help to share it. If you have the means and you would like to support the channel, I have a link to my PayPal below. Any donations will be very much appreciated. Thank you.